Good morning everyone, how are you? Today we will start a new part and section in chapter 18, section 3. But before we will start, we have to highlight for some important points to understand our section today. As you know, this section is about 29 slides, but these 29 slides, half of these slides just revision and highlighting for important parts from the last semester and this semester. And you have to understand these points. You have to know, as I told you inside the class, chemistry is a build-up subject. You should understand everything before to understand the upcoming information or upcoming sections. So now you have to understand and study self-ionization of water and how to calculate the hydronium ion or hydroxide, the concentration of hydronium ion or the concentration of hydroxide ion. Kw is the ionization constant of water, which equal 1 times 10 power minus 14. Okay, so the concentration of hydronium ion is half of this value. So concentration of hydronium ion is equal 1 times 10 power minus 7 molarity, and the concentration of OH the same. This is the self-ionization of water. The second slide explains that the ionization constant can be calculated at specific temperature. So for each temperature we have a specific Kw. Like as you see, this is room temperature and this is the ideal ionization constant, but if the temperature decreased or increased, Kw will change. And these values explain H3O, the hydronium ion, if it more than this value, so the solution will be acidic. If less than, the solution will be alkaline. And these calculations, we explained it before. As you see, this slide is very important for our section today. It classifies the strengths of acids and bases. You should understand that HClO4, which is hydrogen biochloride or biochloric acid, this acid is the strongest or strong acid in chemistry. HI is a strong acid, HNO is a strong acid, HCl is a strong acid, HBr is strong acid, H2SO4 is a strong acid. Strong base like NaOH, calcium hydroxide, potassium hydroxide, cesium hydroxide, lithium hydroxide, and so on. Weak acids like HCOO, HNO2, CH3COH, and we take this example, HCN, HF. You should understand that HF is a weak acid, but HR, HCl, HBr are strong acids. Why? This is according to the electronegativity. Electronegativity of fluoride is the highest electronegativity in the periodic table. So the bond between this H and F is very strong, very strong. So the ionization of HF in water is very weak. So it is weak acid. And you understand that the weakness or strength of acids and bases is according to the ionization in, or the degree of ionization in water. Now, weak base like NH3, CH3 or 2NH, CH3NH2. We will concentrate in this section for these parts, specifically HI, HCl, HNO3, HBr, H2SO4, and NaOH, COHO2, KOH, and weak acids like CH3, COOH, or HF, weak base like NH3. This is another classification present in your book. You have to understand this table. Now, how to build the ionization constant or equilibrium constant equation. You know, K is the equilibrium constant, which is equal concentration of the products over the concentration of the reactants. C is a product power coefficient, D is product power coefficient over A is reactant power coefficient, B is reactant power coefficient. Sorry. Here are some calculations. You should review these calculations. This is another equilibrium constant, K equal HI, concentration of HI power 2. Why power 2? Because you have here coefficient 2. We studied the acid ionization constants, Ka, and by the same way, acid ionization constant, Ka is equal, like here, the concentration of the reactant, of the product, sorry, over the concentration of the reactant, and the neglecting the H2O, concentration of H2O, because it has self-ionization, so it is neutral, so it has no effect in this equation. So Ka equal concentration of hydronium ion power coefficient times the concentration of acetate ion power coefficient over the concentration of the acetic acid power coefficient. This slide is very important because it explains, as we mentioned before in the first semester, how to determine the acid or the base. We have three main theories. The first theory is Arrhenius theory, the second one is Bronsted-Lowry theory, the third one is Lewis theory. Today we will highlight for the Bronsted-Lowry theory, which explains the acid is the part of the reaction which donate proton, and the base the part of the reaction which accept the proton. So now in this side, HA is the acid. Why? Because it donate proton to the B, and B is the base. So HA is Bronsted-Lowry acid, and B is Bronsted-Lowry base. On the other side, now the anion part which remain from the acid is called conjugate base. Okay, and the other part, now the hydrogen ion or the proton which will move to the base, this part is called conjugate acid. So here acid, this base, A minus is conjugate base from the acid, and this part is the conjugate acid from the base. Okay, now you understand this slide. Study it well. It is very important. We finished in these lessons ionization constant of a weak acid, buffers, and what is the meaning of buffers. The ionization constant of water, we explained it before, and we understand what the meaning of self-ionization of water. We will study today hydrolysis of salts. This is our objectives in this section. Now, ionization constant of water. The self-ionization of water is an equilibrium reaction. Why equilibrium reaction? Because the concentration of H3O equals the concentration of OH, so there is no change in the pH. So the equilibrium is established with a very low concentration of hydronium ion and OH. So now Kw equal the concentration of the hydronium ion times concentration of hydroxide ion, which equal this value as mentioned before. Before we will explain this slide, we have to review the next slide. Here, neutralization reaction, acid plus base will produce salt plus water. Acid like HCl, base like NaOH will produce salt like NaCl and H2O. Another example, acid like HNO3, these two acids are strong acids, plus NaOH, NaOH is strong base, they will produce the same NaNO3, sodium nitrate as a salt, and H2O. Now return to the last of the previous slides, hydrolysis of salts. Salts are formed during the neutralization reaction between a pronisted acid and a pronisted base. So HCl is a pronisted acid. Why? Because it donates proton, and NaOH is a pronisted base. Why? Because it accepts this proton. When a salt dissolves in water, it produces positive ion, which is the cation of the base from which it was formed, negative ions, which is the anion of the acid from which it was formed. So in this slide, NaCl will be formed from what? From the cation part of the base and the anion part of the acid. You know, this H is called cation. Why? Because it carry positive charge. Cl carry negative charge, which called anion. So NaCl is formed from the cation part of the base and the anion part of the acid. So here, if the ions formed are from weak acids or bases, they react chemically with the water molecules, and the pH of the solution will have a value other than 7. So as you understand before, neutralization reactions means this is equivalent reaction between acid and base to reach what? To reach neutralization. Neutralization means pH equals 7. Now, if you have any disturbance in this neutralization reaction and the strength of the acid or the base, what will happen? The pH will shift according to basics, and these basics we will explain them today. But before we will explain these basics, we have to understand what's the meaning of hydrolysis. We can divide this word to two parts. Yes, hydro and lysis. Hydro means water. Lysis means breakdown, okay, of salts. So if we add or dissolve salts with water, it will be hydrolyzed. Hydrolyzed means it will be broken down. Broken down to what? To ions. So, our section today. This is the main equation. Acid plus base will produce water plus salt. What happened to this salt after this reaction? It will also hydrolyze in water because it has here water. So we have four options in this chemical reaction. The first one is reaction between strong acid and strong base, which will produce water and salt. But this strong acid, what's the meaning of strong acid? Strong acid means it completely ionized. And what's the meaning of strong base? Strong base means it is completely ionized. So what will happen to the results? Do you have any change in the pH? No. Why? Because it's completely ionized and this part is completely ionized, so they will form equivalent amount of water and salt, so there is no change in the pH. This is the first case of our section today. The second case, if we react weak acid and weak base, what will happen? The same like before, like the first case. If we have weak acid and weak base, the degree of ionization will be the same. So the pH of the product will be changed or no? No, because the degree of ionization of the weak acid and the weak base are the same. So the pH is also constant. It will be neutral. So here we have case 1 and case 2. Case 1, strong acid and strong base. The products will be neutral, so there is no change in the pH. Weak acid and weak base, also there is no change in the pH. But if we react weak acid with strong base, what will happen? This weak acid means the ionization is very weak, and strong base means the ionization is very high. What will happen? The solution of the salt will be basic. Why? Let us jump to next slides. Here you have here weak acid and typically weak acids and strong base. This weak acid will produce HA, like which one? Reaction between weak acid and strong base means anion hydrolysis. Anion hydrolysis, these anions come from the weak acids. So in the constant, since the anion of the salt is the conjugate base of the acid as mentioned before, from which it was formed. It is also a proton acceptor. If the acid is weak, its conjugate base, which is the anion, will be strong enough to remove proton from some of water molecules, like this light here. This is the anion part which will react with water. This is the anion part from what? From the reaction between weak acid and strong base. They will form what? Hydronium ion and A negative. Okay, this A negative, which is the anion part of this acid, will be hydrolyzed in water to form what? To form Ha plus OH. This OH will reflect the increasing in the basic solution of the reaction between weak acid and strong base. So the extent of OH ion formation and the position of the equilibrium depends on the relative strength of the anion part. This anion part, as mentioned before, comes from what? From weak acid. So this anion part in the first equation will be present in the right side, and in this right side we have water molecules. This A negative will hydrolyze in water molecules to form again Ha. So A negative will accept proton from water and release the OH group in the solution, which will reflect the basicity of the solution or the alkalinity of the solution. So again, case 1, reaction between strong acid, strong base. Case 2, weak acid, weak base. In these two cases, there is no change in the pH. Why? Because the degree of ionization is constant and equal, so there is no change in the pH. Case 3, which is a reaction between weak acid and strong base, what happens? These weak acids, the anion part of this weak acid is strong, which will react with water molecule to form what? To accept a proton from water molecule and release the hydroxide group in the solution and increase the alkalinity. Example of this case is the reaction between carbonic acids and sodium hydroxide. Okay, what will happen? Carbonic acid and sodium hydroxide, reaction between acid and base. Acid is the carbonic acid, H2CO3, and sodium hydroxide, NaOH. What will happen? This is double displacement reaction. What will happen? Sodium carbonate will form. This sodium carbonate is present in the product and it will hydrolyze in the solution to sodium ion and carbonate ion. Sodium cation comes from sodium hydroxide and carbonate anion comes from carbonic acid, and carbonic acid is weak acid, so carbonate ion is strong ion which will hydrolyze in water to form what? To accept one proton to form HCO3 minus 1 and this hydrogen carbonate ion, and what? and OH group. So reaction between weak acid like H2CO3 and strong base like NaOH will produce what? Will produce Na2CO3 sodium carbonate, and this sodium carbonate will dissociate or will hydrolyze in the solution to sodium cation and carbonate anion. This carbonate anion can react with water molecules present in the solution to form this ion and OH group. This OH group reflects the alkalinity of the solution. So reaction between weak acid and strong base will produce what? Will produce alkaline solution. So weak acid can be hydrolyzed and produce alkaline solution. But strong acid, strong base, they cannot be hydrolyzed, so the solution neutral. Also weak acid and weak base, they cannot hydrolyze, so the solution, there is no change in the pH of the solution. The last case is cation hydrolysis. The third case is anion hydrolysis between weak acid and strong base. Here cation hydrolysis between what? Between strong acid and weak base. This cation hydrolysis comes from what? This cation comes from the weak base, as we mentioned before. The salt formed between the reaction of acid and base is formed from anion and cation. Cation comes from the base, anion comes from the acid, and we explained case 3 as anion hydrolysis. Now we will explain cation hydrolysis. So this cation part comes from a weak base. Okay, like this reaction. This B is the base. When it will react with H2O in the solution, it will produce pH positive. pH positive is anion or cation. It will be cation. This is cation. Why? Because it carry positive charge. And OH minus. This pH positive will hydrolyze again in water to, here this pH positive will react again with water to produce what? To produce hydronium ion and be in the aqueous solution. This hydronium ion will shift the pH to the acidic or alkaline to the acidic. So the solution which is resulting from the reaction between strong acid and weak base, this solution is alkaline or acidic? It's acidic. Why? Because it contains hydronium ion, and hydronium ion is acid in nature, because it will decrease the pH of the solution. Okay, so here the pH positive will donate hydrogen or proton, or will accept proton. It will donate this proton to the H2O to form H3O positive hydronium ion, and this P will release in the solution. So the solution contains H3O, which reflects the acidity of the solution. So the extent of H3O positive ion formation and the position of the equilibrium depend on the relative strength of the cation pH positive. So salts which will be produced from reaction between acid and base can be placed in 4 general categories depending on their hydrolysis properties. Hydrolysis properties of what? Of the salt. If this salt formed from strong acid and strong base, there is no change in the pH, so there is no hydrolysis. If the salt comes from weak acid and weak base, the same like the first case. There is no change in the pH and the solution is neutral. That means there is no hydrolysis of the salt inside the solution. Okay, in between this we have two other cases. The reaction between strong acid and weak base, strong acid and weak base, so the salts which will result, what will happen? Like last slide, the salt will change the pH, the salt will hydrolyze and change or shift the pH to the acidic solution because you have strong acid. Okay, if the solution or if the salt comes from weak acid and strong base, what will happen? Now the solution of the salt will be hydrolyzed and the solution will be alkaline solution. So the first case, no change, no hydrolysis. The second case, there is hydrolysis to what? To acidic. The third case, also there is hydrolysis to what? To alkalinity. The last case, weak acid, weak base, like the first, there is no hydrolysis, so there is no change in the pH. Hope to understand this long section. Thank you. Bye.